This is a logs question. Now, starting with a, we want to show that 3 log a cubed x equals log a of x. Very well. The best way I can imagine to do this is with a change of base rule. So 3 log base a cubed of x. This is going to equal to 3. I'm going to choose, and here we want to end with log base a. Log base a of x over log base a of a cubed. This is 3 log base a of x over 3 log base a of a. Now the 3's cancel out, and log base a of a is just 1, leaving us alone with log base a of x, which we've demonstrated. Okay. If you're not too sure on the change of base rule, it is available in your formula booklet. And what you do want to remember is that for anything in this form, you can choose any base of your choice. And it's the top over the bottom. And this will work all the time, and it's quite useful. Now, we're looking at log base 2 of y plus log base 8 of 4x squared plus log base 8 of 2x equals 0. And what I think is worth noticing is that 2 and 8, we just answered a question on a cubed. So if a was 2 right here, 8 would equal a cubed. So that I imagine what we've just discovered, what we've just shown, will be useful here. Let's move on to b and find out. Well, we've got log base 2 of y. And now by log properties, with the same base, we can multiply 4x squared by 2x. It's equal to 0. Log base 2 of y is equal to log, plus log base 8 of 8x cubed equals 0. And now, I could move both of these right off the bat to base 2's, doing much of the work we just saw. So I'm going to do this in 2 different ways. I'm going to start with a change of base, which I think is perhaps the most obvious. And another one that, with a little bit more intuition, gives you something nice. So, am I doing this right? Yes, I am. Log base 2 of 8 is 3. So this is log base 2 of y is equal to negative 1/3 log base 2 of 8x cubed. So that y is equal to 8x cubed, the power of negative 1/3, which is equal to 1 over x cubed third, which is 1 over the cube root of 8 is 2, and the cube root of x is x. And so that's what we have. All right. And we wanted to give our answer in the form y equals bxc, where b and c are constants. Well, in which case I can rewrite it like this. No, b is 1/2 and x is -1. Okay, that should be fine. But just to make it more in that form. That's because there was this requirement right here. And so I'm being very explicit for the examiners that this is my c up here. Now the region R is bound by the graph of the function and the lines x equals 1 and x equals k. So here we're just calculating the area of the region. The reason why k is greater than 1, okay, so c, we calculate the area from x equals 1 to x equals k of the graph of the function, and we just found this function right here. This is 1 over 2x and we're told that this is equal to 3 over 2, and we need to find k. So this is equivalent. I'm going to pull out the 1/2 just to make it quite clear. This is ln of x. Oh, no, we're done. So I've got 1/2 ln k minus 1/2 ln of 1, and this is equal to 1/2 ln of k minus, the ln of 1 is 0, and this was equal to 3 over 2, so that, well, ln of k must equal 3, and this in turn means that e cubed equals k. It's an interesting question. I think we didn't use, in the second part, this form. And if you wanted to, really you would use it right here. And you would do that by recognizing that log base 8 of 8x cubed is equivalent to log base 8 of, well, let me rephrase it, to log of 2 cubed of 2x cubed, which would be 3 log base 2 cubed 2x. And that would allow you to find this form right here. And if you see that, that's good. I mean, frankly, that's pretty smooth. I think this is perfectly acceptable as well. And certainly this will work all the time without the need for intuition. If you can develop the intuition, great. If you start stressing, remember that the basics will always work for you. And I think that that's all the problems that you asked.